Good day everyone, once again I'm Saeed from BTC. Today we'll be talking about chemistry and our topic is classification of alkanol. Before we proceed on to classification of alkanol, what is alkanol? Alkanol are a group of organic compound which is being obtained through the replacement of one hydrogen from an alkane by hydroxyl group. So let's assume you have an alkane. What you are going to do to the alkane is just to remove one hydrogen, and once you remove the hydrogen, it will change from alkane to what? To alkyl group. So then after it has been changed to alkyl group, you now add hydroxyl group, which is now OH. So alkyl plus OH will give us alkanol. So let's take a look at the typical example. We have the first member of alkane group to be methane, so which is also being referred to as marsh gas. So we have methane to be CH4. Now you remove one hydrogen, that is minus hydrogen. What are you going to have? You have your methyl, which is CH3. Then to your methyl you add OH, so plus OH. So at the end of the day we are going to have methanol, which is CH3OH. So this has now changed from being alkane, so we have alkane here, to alkanol. So whenever you are talking about alkanol, there must be an hydroxyl group, which is OH. So the general formula for alkanol is R, which is alkyl. These are alkyl. We have our R, then you have OH. This is the general formula. Or if you don't want to use this, you can still replace it with the formula for finding an alkene, which is CnH2n plus 1OH. So this is the other formula for alkanol. So that's all about the introduction of alkanol. The next thing we are going to do now is classification of alkanol. Let's start. Okay, the classification of alkanol is based on two major criteria. The first criteria, so let us use the table. We have alkanol. So if you want to classify it, the first one is based on number of hydroxyl group. Based on number of hydroxyl group. Okay, we have hydroxyl group, which is OH. The other one is based on the number of alkyl group surrounding the hydroxyl bonding carbon. So those are the two different ways of classifying an alkanol. The first one based on number of hydroxyl group, while the other one is based on number of alkyl group surrounding the hydroxyl bonding carbon. So now let's start with the first method of classification, which is based on number of hydroxyl group. The first type is called monohydric alkanol. So when you are talking about monohydric alkanol, as we all know that alkanol can also be referred to as alcohol. So we have alcohol. Okay. So we can also refer to as monohydric alkanol as monohydric alcohol. So from mono, we all know they are talking about one, and hydric, that's hydroxyl group. So these are alkanol with one hydroxyl group. That's monohydric alkanol. Okay. So a typical example are all those normal alkanol like methanol, ethanol, propanol, butanol, etc. All of them are monohydric. For example, okay. E.g., this one they have 1 OH. Example, These are the examples. We have the methanol. Methanol. And what is the formula for methanol? Don't forget our normal formula CnH2n plus 1OH. As you can see, the N for methanol is 1. So we are going to have C1. H, we have 2 multiplied by 1, 2 plus 1, 3. So we have H equal to H3 O to OH. So you remove the 1, we don't put 1 there. So we are going to have CH3 O to OH. So that is the first example. As you can see that in this methanol, there is only one hydroxyl group. So other examples that you can talk about is now they are okay. We have the ethanol to ethanol, which is the second member and the second and most important member, and we have the formula to be N is 2. So we are going to have C2H 2 multiplied by 2, that's 4, plus 1, that's 5. 5 O to OH. So we have C2H5OH. So moving on, we can just be adding CH2. As we all know that in homologous series, each successive member divide by CH2 group. So we can just be adding them. The third one, which is propanol. So we have the propanol. So the formula will now be add CH2. Instead of C2, it will be C3. We have 2 hydrogen. We have H5. O to OH, that's propanol. We have the next one, we have butanol, which is the number what? Oh, number 4. So that will be what? So C, you have CH2 again. Okay, so this one butanol is C4H. Okay, don't forget. Hey, sorry everyone. So don't forget that we are adding CH2 to this to get this. So instead of C to H5, it will be C3. You add 2 to this hydrogen, it will now be H2 to H7. Okay, that's propanol. Sorry about that. We have the butanol to be C4H, add 2 to H7, that will be H9OH. So we have the next one, which is what? To pentanol. So we have pentanol, which will now be what? To add CH2 again, C5H11O to OH. So the next one is hexanol to hexanol. Hexanol will also be what? To C6, add H2, H13, O to OH. So that's all until we get to decanol. So we can all see that in all these alkanol, how do we know that they are alkanol? There is OH, hydroxyl group there. That's how we know that they are alkanol. But how do we know that they are monohydric? Because they have only one hydroxyl group. That's why we call them monohydric alkanol. Monohydric alkanol. Okay? So that's regarding monohydric. Another type that we have is called what? Dihydric. From the word di, we all know what we mean by that. So we have the dihydric alkanol. Dihydric alkanol. So what do we mean by dihydric alkanol? So what do we mean by dihydric alkanol? From the word di, that's 2. Hydric, that's hydroxyl group. So these ones, they have 2 hydroxyl groups. So they have 2 O to OH. They have 2 OH in their compound. Okay. So what are the common examples in this one? And don't forget that apart from calling this thing dihydric, you know we said hydric is hydroxyl, or you can also say alkanol. Alkanol. So we can also replace this hydric by or. It will now be di. Instead of using hydric, it will now be diol to diol. So we can call this dihydric alkanol as diol to diol. Or if you don't like diol, sometimes they are also being called what to glycol. So you can also call them glycol or glycol. And we all know some common example of glycol that we have. You can talk about the ethylene glycol. You can talk about the what to the propylene glycol. All those are examples of glycol. So let us take a look at examples of dihydric. Okay, we have the first example. We can't have methanol there, like we can't have anything met. I mean the first member, because when we are talking about dihydric, there has to be 2 OH, and the OH has to attach to a carbon, so it must have more than 1 carbon. So we are starting with the second member. For the second member, we have let me just use number 2. Okay, number 1, example 1 for dihydric. We have ethylene glycol, which is also called ethane 1,2-diol, or if you like, you can call it ethylene glycol. Ethylene glycol, can call it that. So, and what's our structural formula? What's the structural formula for this one? As you can see, ethane 1,2-diol. Ethane 1,2-diol. So let us write what's the formula for ethane. We have C. We are supposed to have C2 H2O2H6 like this. You can split this one into two. It will now be CH3. So I can write it as CH3, and we also have CH3. So what we have? We want to turn it to ethane 1,2-diol. On carbon number 1, we are going to have OH. That is, you remove one hydrogen. So instead of having CH3, it will now be CH2. You now put OH. So we have OH. The same thing applicable to this one, because they said ethane 1,2-diol. That is on carbon number 1, that is O group or hydroxyl group. On carbon number 2, there is also hydroxyl group. So on that carbon number 2 also, you remove one hydrogen again, you put 2O2, and you put your OO2OH. So this is the formula for ethane 1. On carbon number 1, we have OH 1,2-diol. So that's for the first one. The second common example that we are going to talk about is propylene glycol, or propane. You can call it propane 1,2-diol, like this. Oh yeah, how do we write the structural formula? If you want to write the structural formula, we have propane, which is what's the formula for propane? We have C3, that's H8. Okay, so if you want to split this thing, we can split it now. We are now going to have CH3, we have CH2, and we have CH3, like this. So now we want to turn it to, because they said we have propane 1,2-diol. That is, we have OH on carbon number 1. We also have another OH on carbon number 2. So on carbon number 1, remove one hydrogen and replace it by OH. So we are going to have CH2OH. Then what about this one? What do we have? We have CH. You remove one hydrogen, replace it by OH. OH. Then we have CH3. So this is the formula for propane 1,2-diol. Or you can also call it what? You can also call it propylene glycol. Propylene glycol. So that's another formula. So once you hear the word glycol, you should know that they are talking about what? Alkanol with 2 hydroxyl group. And another thing that is special about them is that they have a very strong hydrogen bond. You know, when you are talking about hydrogen bond, it is a bond from when hydrogen is bonded. It's been bonded to a strongly electronegative element like halogens, like chlorine, fluorine, and also the group 5 like nitrogen, and also the group 6 like water, like oxygen. So when you see hydrogen being bonded to oxygen, there will be hydrogen bond in their molecule. So this alkanol, the main reason why alkanol is very soluble in water, or is readily soluble in water, is due to the presence of this hydrogen bond. And that's also the reason why they have high boiling point. So the stronger the hydrogen bond, the stronger their boiling point, or the higher their solubility. So this dihydric alkanol they have 2 OH. They have higher boiling point and higher solubility than monohydric alkanol with 1 OH, because the hydrogen bond of dihydric will be more than that of monohydric. So that's that. Another thing, very important thing that is usually being asked in exam, WAEC JAMB, NECO Post-UTME, is that this glycol, both the ethylene glycol and the propylene glycol, they are a very good antifreeze. That is, they can be used as a coolant. In fact, some of them are being used as as an antifreeze in car radiator. Let us take note of that. It is a very common question. Now, moving on away from dihydric alkanol, the next one is is trihydric alkanol. So we have the trihydric alkanol. From the word trihydric alkanol, I believe we all know what we meant by that. Tri, that's 3-hydric, that's hydroxyl. So these ones they have 3 hydroxyl group, 3 OH in their molecule. And a very common example that we can talk about is what we have the glycerol, which is also being referred to as propane 1, 2, 3 triol. You can see from tri, you see tri, you know that's spelling now 3. Triol, that's OH. Triol, 3 OH. Diol, 2 OH. This one there is only O, that's 1 OH. So propane 1, 2, 3 triol. This is also known as glycerol, or you like glycerin. So glycerol. It is an important product which is being produced during saponification. That is production of soap. Okay, so what is the formula of this propane 1, 2, 3 triol? The first thing is for us to know that we have propane, Abby. And what is the formula for propane? Okay, we have CH3, we have CH2, and we have CH3. You can see this is propane, Abby. So which is the same thing as C3, 1, 2, 3, C3, H what? H. Okay, from here, you now say propane 1, 2, 3 triol. That is, there is O or OH on carbon number 1. There is another O on carbon number 2, another O on carbon number 3. So what can we do? You can change it like this. CH3, instead of CH3, you remove one hydrogen. We are now going to have CH2OH. Then we have another one which is CH. You've removed one hydrogen, replace it with OH. And the third one on carbon number 3, you remove another hydrogen, and we're leaving CH2, then you have OH. So this is propane 1, 2, 3 triol, which is also being referred to as glycerol. So those are the 3 common types of alkanol based on number of hydroxyl group. We also have another additional one which is being referred to as polyhydric. Okay, let us call it polyhydric alkanol. Okay, sorry. Let me just bring this one here. So we have CH2OH, we have CHOH, and we have CH2OH. Okay, so let us talk about the polyhydric alkanol. Polyhydric. So for the word poly, you know what poly means. So in this case, we are going to consider it as those alkanol with 3 or more hydroxyl group. Though sometimes they consider it as 2 or more. We may see them calling dihydric and trihydric under polyhydric alkanol. But here we are going to be talking about alkanol with more than 3 OH. So let's take a look. Okay, we have 3 or more. 3 or more. Okay, OH. Okay. What are our common example of this polyhydric alkanol? One very common example is something called we have the sorbitol, we have the mannitol, and we even have some carbohydrate like glucose. Even they have more than 3 hydroxyl group in their molecule. But a very common example that I'm going to use is sorbitol. When you are talking about sorbitol, it has 6 hydroxyl group in its molecule. Let's see. Sorbitol, we have CH2OH. So we have C. Okay, we have OH. We have H. Here we have C. We have H. We have OH. Moving on, we have C. We have OH. We have H. We have C. OH. We have H. We have last C, 1, 2, 3, 4, 5. We have CH2OH. So you can see, this thing is called sorbitol. It is being referred to as sorbitol. I don't know whether you can see it properly. Let me rewrite it. We have CH2OH. We have C, OH. We have H. We have C, we have H, we have OH, we have C, OH, we have H, we have C, you have OH, you have H, you have C, H2, CH2, OH. You can see here that 1, 2, 3, 4, 5, 6. You can see here that the dominant functional group here is OH. And if you count the number of this OH, you have 1, 2, 3, 4, 5, 6. There are 6. There are 6 OH. You can see this thing is hexane. We have 6 carbon. That's hexane, and each carbon atom. So you can say hexane. 1, 2, 3, 4, 5, 6. There are 6 6 hexane. And there are 6 OH, 6 hydroxyl group in this sorbitol. So we call this sorbitol, which is a typical example of of alkanol with more than 3 hydroxyl group. So that's about classification based on the number of hydroxyl group. Note that apart from this sorbitol, we still have some other one like mannitol. We have even our glucose has more than it has more than 3 hydroxyl group in its molecule. Now that's all about the first classification of alkanol, which is based on the number of hydroxyl group. The other classification is now based on based on alkyl group. Let's start. Okay, so now to the second mode of classifying alkanol. So as we said earlier, the second mode of classifying alkanol is based on the number of alkyl group surrounding the hydroxyl bonded carbon. So let's see. We have the first one, the first type under here. We have the primary alkanol. So we have the primary. Okay, our first degree alkanol. So that's our first one. And what is primary alkanol? They are the alkanol whose hydroxyl bonding carbon, that is hydroxyl bonding carbon, is being attached to only one alkyl group. That is, we have the hydroxyl bonding carbon is being attached to only one alkyl group. Okay, so that is our primary alkanol. The hydroxyl bonded carbon is being attached to only one alkyl group. So a typical example is our common alkanol. Like, let me start from the first example. We have the ethanol, like which is CH3 CH2OH. So let me separate it. Also, let's rewrite it as C. We are being surrounded by H. Then we have CH2, CH. Then we have OH. So if you take a look at this, don't forget this is just ethanol, which is C2H5, C2H5OH. Okay. So this ethanol, let's take a look. How do we know that it is a primary alkanol? The first thing, identify the hydroxyl bonding carbon. That is the carbon atom that is bonded to that is being bonded to the hydroxyl group. So taking a look at this structure, where is the carbon? You can see this carbon here. It is being attached to the OH. So it is our hydroxyl bonding carbon. So the first thing is for you to identify it. Once you've now identified it, the next thing to do is now to count the number of alkyl group that is being attached to it. Sometimes I just use carbon instead of using alkyl, but the correct one to use is is alkyl group. But I've been using carbon here. Now let's take this carbon, the hydroxyl bonding carbon. How many carbon is being attached to it? You can see we have only one. You can see this bond. you can see that it is only this carbon that is attached to the hydroxyl bonding carbon. So because we have only one alkyl group, you can see the alkyl group, which is CH3, being attached to this carbon. That is why we call it primary alkanol. So primary alkanol are alkanol in which the hydroxyl bonding carbon is being attached to only one alkyl group. That's primary alkanol. We have many examples. Another example is you can just be using your common, all those your common alkanol. That is alkanol that has OH on carbon 1. On carbon 1, like methanol, like ethanol, like propanol, like butanol, hexanol, heptanol, all of them, you know, if you want to write propanol is the same thing as propa1-ol. So that is the OH is on carbon number 1. Any of those alkanol that you see their OH on carbon number 1, they are usually primary alkanol. So let me use another example. Let's talk about propanol. But I can still rewrite propanol as propa1-ol. Propan1-ol, like this, or if you like, you can call it propanol. Anyone is okay. Oh yeah, what is the formula of this propanol? Don't forget we have pro, which is 3 carbon. So we have 3, 1, 2, 3, like this. So you now attach all of them. Okay, on carbon number 1, we have 1-ol, that is ol on carbon number 1. So let me just put the ol here, OH. Then, you know, carbon must be surrounded by 4 bonds. So you surround, okay, carbon. So this is 1, 2, 3, 4. What about here? 1, 2, okay, 3, 4. 1, 2, 3, 4. So then you put hydrogen, 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 hydrogen. So this is now propanol or propa1-ol. So now, how do we know that it is primary alkanol? We just, the first thing, identify the hydroxyl bonding carbon. Oh yeah, where is our hydroxyl bonding carbon? This is hydroxyl, so this is hydroxyl bonding carbon. Okay. Once you've now identified it, the next thing is to take a look at the number of alkyl groups surrounding it, or the number of carbon surrounding it. Don't forget, that carbon that we are talking about must be the one that is being attached directly to the hydroxyl bonding carbon. For example, if this is our hydroxyl bonding carbon, so which carbon is attached to it? Only this. Only this. So we only consider only this. So you don't need to consider this one with this bond. Or you can say we have only this thing being attached to the water, to the carbon. This is the alkyl. Everything here is an alkyl group. You know, we can call it alkyl. And what's the name of this alkyl? CH2, CH3, or C2H5. That's ethyl. I mean, so we have only one alkyl being attached to it. Don't forget, this is just one alkyl. This alkyl just has it has 2 carbon, so it doesn't matter. So it may be propyl, it may be butyl, it may be pentyl. In as much as we have only one alkyl group, we don't want to know whether it is methyl, ethyl, or anything. You call it what? Primary alkanol. Or to make it easier, I usually use carbon. I use carbon, and that carbon must be the one with direct contact with what? With hydroxyl bonding carbons. Okay, let's take a look at this. So if you take a look at this, you see that these are hydroxyl bonding carbon. Hydroxyl bonding carbon. So how many carbon is being attached to it? Only this. Only this one is being attached to it. So it is primary alkanol. So that's about primary alkanol. You can give another example. Let's talk about pentanol or penta1-ol. Or you can also have some other one like that, but your OH must be on carbon what to carbon number 1. Let me use another one to branch. Let's say you have 2-methyl buta1-ol, or 2-methyl butanol, anyone you like. Let's take a look at this. How do you know that it is a primary alkanol? The first thing you draw your word to, you start your drawing from buta1-ol. So let's start. But is how many carbon? We have 4. We have C, like this, having. So on carbon number 1 we have OH. So I can assume this is my carbon number 1. And if you like, I also use this as a carbon number 1. So we have OH being attached to this carbon number 1. What's the next thing? They said 2-methyl. That is methyl is on carbon number 2. So where is your carbon number 2? Don't forget the carbon atom containing OH must be carbon number 1. Then the next carbon will be carbon number 2. So we have here we have CH3. You can see these are 2-methyl. Then you complete everything. Okay, we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. So just put hydrogen, 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 hydrogen here, and hydrogen here. So these are our 2-methyl, buta-1 to buta-1-O. So now let's take a look. Is it truly a primary alkanol? The first thing, take a look at hydroxyl bonded carbon. So these are hydroxyl bonding carbon. So if these are hydroxyl bonded carbon, how many carbon is being attached to it? That is having a direct connection to it. You can just say this. You don't need to consider there are some carbon like this, and like this. Which one has direct contact? How many have direct contact with it? It is only this. So we just refer to all of them here like alkyl. So they are just one alkyl like that, which is butyl. You can see that there are 1, 2, 3, 4. This is butyl. So it is one alkyl being attached to this carbon atom. So it is still primary alkanol. Okay, that's our primary alkanol. Let's take a look at secondary alkanol. So when you are talking about the secondary alkanol, so don't forget that we have 2 hydroxyl group. We have secondary alkanol. In our secondary alkanol, we have the hydroxyl bonding carbon is being attached to 2 alkyl group. Okay, sorry. 2 alkyl. Okay, we have something like this. So in the secondary alkanol, the hydroxyl bonding carbon is being attached to the 2 alkyl group. As you all know that example of primary alkanol, they are actually the one with 1 or you won't see any number there, like ethanol, propanol, propa-1-O, buta-1-O, butanol, pentanol, hexanol, hexa-1-O, hepta-1-O, and the likes. That is, our hydroxyl group is on carbon number 1. Those are for the primary alkanol. What about for the secondary alkanol? The hydroxyl group is usually not on carbon number 1. You can see the hydroxyl group on carbon 2. You can see it on carbon 3, on carbon 4. In many places. Okay, let's take a look at some typical example. Okay, let's assume we have propan-2-O. Propan-2-O. Don't forget, 2-O simply indicates the O, which is OH, or hydroxyl group, is on carbon number 2. So now let us draw it. Propan-2-O. The first thing you draw your propane. So we have C, like this having. Carbon number 2, there is OH. So let's say this is carbon number 2. We have OH. So that's all. You just complete your diagram. So we have 4 bonds to be surrounding carbon. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like this. Okay, put hydrogen. So we have something like this. So this is propan-2-O to propan-2-O. How do we know that it is a secondary alkanol? For the first thing is that you identify the hydroxyl bonding carbon. So where is hydroxyl bonding carbon? That is the carbon atom that is being bonded to OH. This is the carbon atom. As you can see, this is your OH. This is the carbon bond being bonded to it. So if you these are hydroxyl bonding carbon. You can see it. Then how many alkyl group, or let me just use in simple terms, how many carbon is being attached directly to it? Okay, you can see this bond, it is being directly attached to this carbon 1, it is also being attached directly to this carbon 2. So we have 2 carbon surrounding the hydroxyl bonded carbon. Or you can say 2 alkyl group. You know this is an alkyl. Okay, this is another alkyl. Surrounding the hydroxyl bonded carbon. That's why we call it a a secondary alkanol. Number 2, we can have another example. We have butan-2-or. The same thing. We are still going to have it. Okay, let me use butan-2-or. Butan-2-or like this. Okay, so what's our structural formula? You know, but that's 4 carbon. We have 1. Okay, so we have 1, 2, 3, 4. So on carbon 2, you have your OH2O. So let me say this is my carbon 2 and this is my OH. Then you finish the rest of the diagram. 1, 2, 3, 1, 2, 1, 2, 3. Okay, so we have like this, like this, like this. Okay, we have like this, like this. Okay, so these are butan-2-or. So if these are butan-2-or, how do we know that it is a secondary alkanol? You just identify the hydroxyl bonded carbon. So this is the carbon that is being attached to the OH. So how many carbon is directly attached to it? So or how many alkyl group are directly attached to it? We have, you can see a bond here, which is to this carbon. You can see another bond here, which is to this carbon. So we have 2. You can see them. We have 2. Let me be showing those bonds that is being attached to our hydroxyl bonded carbon. In here you can see this is the only bond that is being attached to it. In here you have you have only this one being attached, and in here you have only this one being attached. Okay, so you can see that there are 2 alkyl groups surrounding the hydroxyl bonding carbon. Or you can say, okay, let me use this. So this is our hydroxyl bonding carbon. Okay, this is our hydroxyl bonding carbon here. So what are the alkyl? Where are the alkyl groups? So this is 1. You can see 1 here being attached to it. You can see another 1 here being attached to it. Those are the 2 alkyl groups which are being attached to the hydroxyl bonding carbon. But you can see there are 2 different groups. This one is ethyl, and this one is methyl. Doesn't matter. It's still secondary alkanol. But if you don't want to use alkyl group, the easiest thing is just to use the carbon. You can see how many carbon attach directly to it. Directly. You know, you can't count this carbon because it doesn't attach directly to this carbon. So, but this one direct connection. This one direct connection. That's why the secondary alkanol. Let's take a look at another example. We have it may not be true though, you know, I use butan-2-or, I also use butan-2-or. It can be other number. Let me use pentan-2-or. Okay, let me use 2-methyl, okay, no. Let me use 4-methyl so that 2 won't be too much. 4-methyl, okay, pentan-3-or. Let me use this. Okay, how do we know whether this one is also secondary alkanol? The first thing, let us draw the structure. You start from here, pentan-3-or. So we are going to pent, which is 5 carbon. So we have your 1, 2, 3, 4, 5. This is pent. Then we have 3-or. That is the OH is on what? Is on carbon number 3. I mean, so we have like this. You can't have 4. Let me just use 2-methyl. So you have 2-methyl pentan-2-or, pentan-3-or. So you can see OH on carbon number 3. So what's the next thing? 2-methyl, methyl on carbon carbon 2. So methyl on carbon 2. We have. I can use this as my carbon 2 or this, anyone you like. So this is methyl. So this 2-methyl pentan-3-or. Then you complete 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you have H, 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 H. So how do you solve this? The first thing is to identify your hydroxyl bonding carbon. So what's our hydroxyl bonding carbon here? You can see that we have this as our hydroxyl bonding carbon. We identify. So this is our hydroxyl bonding carbon. So how many carbon or how many alkyl group are directly attached to it? You can see this one. You can see this over here. Let me use this. And this. Only these are carbon that have been attached to it directly. So it is also a secondary alkanol. So that's about secondary alkanol. Now let us take a look at tertiary alkanol, which is the third type of alkanol. Okay, we have the tertiary alkanol. And don't forget tertiary alkanol. This one they have what? The hydroxyl bonding carbon is being attached to three alkyl group. So that's for tertiary alkanol. The hydroxyl bonded carbon is being attached to three alkyl group. So let's take a look at some examples of this. So one thing you have to note about the examples of tertiary alkanol is that they usually have their alkyl group and OH on the same carbon. For example, e.g. 2-methyl propan 2-ol. Let's take a look at this. 2-methyl propan 2-ol. Let us draw it. You start from here. So you start from here. We are going to have propan 2-ol. 1, 2, 3. Like this. So we have 2-ol. OH on carbon also of carbon number 2. Okay, so you can see propan 2-ol, that is on carbon number 2 there is OH. So let us put the OH. So we have our OH on carbon number 2. What's the next thing? 2-methyl. That is there is also 2-methyl. So on that carbon number 2, we also have 2-methyl. So we are going to have CH3. So you can see methyl on carbon 2, OH also on carbon 2. So when you see methyl and OH on the same carbon like this, it is they are usually tertiary alkanol. Let us confirm. So like to complete our structure, we have 4 bonds that we must surround each carbon. 1, 2, 3, 4. 1, 2, 3, 4. This one is complete. 1, 2, 3, 4. Okay, we have H, we have H, we have H, we have H, H, and H. So these 2-methyl propan propan 2-ol. So from here, the first thing is to identify the hydroxyl bonded carbon. So what's our hydroxyl bonded carbon? So this is our hydroxyl bonding carbon. So how many carbon atom is being attached to it? You can see we have 1. You can see another 1, another carbon. And you can see another carbon up here. You can see it is being surrounded. This hydroxyl bonded carbon is being surrounded by 3 other alkyl group. That's why we can call it tertiary alkanol. Tertiary alkanol. Let's take a look at it. Another typical example. Okay. One thing we have to ensure is that the alkyl group and the hydroxyl group must be on the same carbon. Let us take a look at 3-methyl pentan 3-ol. Okay, now let us draw this one. We start from pentan 3-ol. So we have C. This 5 carbon, which is pent. 3-ol. That is on carbon number 3. There is hydroxyl group. So we have O. So what's the next thing? On that carbon number 3, we also have 3-methyl. We have methyl on carbon 3. So we have on carbon 3 again, we have CH3. Then you just complete your diagram. We have H, 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 H. So this is 3-methyl pentan what to pentan 3-O. So how do you know that it is a tertiary alkanol? The first thing you identify your hydroxyl bonding carbon, and this is your hydroxyl bonding carbon. You can see it. So how many carbon is being attached to it? We have 1, you have 2, and you have 3. Or you can consider it that how many alkyl group is being attached to it. You know, everything here is one alkyl group. Everything here is another alkyl group, which is ethyl. And another alkyl group is up here. You can see that there are 3 alkyl groups being attached to the hydroxyl bonding carbon, and that is tertiary alkanol. You can also see that this thing is very simple. You can easily identify primary alkanol, you can easily identify tertiary alkanol. Any other thing apart from those two will be secondary alkanol. That does the thing. So now let's summarize what we've just done so far. We have a word to alkanol. Alkanol, the organic compound that has OH. We see OH. So that's why we said we have our word to ROH. Or if you like, our R is alkyl group, which can be represented by CnH2n plus 1 over to OH. So based on their mode of classification, we said it can be based on number of hydroxyl group, and it can also be based on what to based on number of alkyl groups surrounding the hydroxyl bonding carbon. Based on number of hydroxyl group, we have monohydric, dihydric, trihydric, and polyhydric. From the monohydric, they have 1 OH, 1 hydroxyl group, dihydric, 2 hydroxyl group, trihydric, 3 hydroxyl group, polyhydric, more than 3 hydroxyl group. You can see some example. Your monohydric, your common alkanol like methanol, ethanol, butanol, any common alkanol that you know. In as much as there is only O, there is nothing like diol, triol, or anything like that. So for the dihydric, I said dihydric are also known as what to diol or diol or what to or glycol. Sometimes diol or glycol. That's dihydric alkanol. You can see a typical example. The ethane-1,2-diol, which is also being referred to as ethylene glycol, and you can see the formula. We have the propane-1,2-diol or propylene glycol. You can see what to the formula. You can see that both of them there are 2 hydroxyl group in their molecule. 2 hydroxyl group in their molecule. That's why we call them dihydric alkanol. And don't forget, when we are talking about this dihydric alkanol or glycol, I told you that they are commonly being used as well to as antifreeze. That is, they help to act as a coolant. They can act as a coolant. All these glycol, either you are talking about ethylene glycol or the propylene glycol. What about the trihydric alkanol? They have 3 OH on their molecule. You can see the typical example, which is glycerol or propane-1,2,3 triol. You can see 3 OH, 1, 2, 3, like this. Those are trihydric alkanol. And we have a polyhydric alkanol that has many OH on their carbon. You can see a typical example like sorbitol. I said another example as mannitol. You can see we have the formula OH, 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 OH. This one has 6 hydroxyl group. Okay, based on the other form of classification, which is based on the number of alkyl groups surrounding the hydroxyl bonded carbon. We have primary alkanol, secondary alkanol, and tertiary alkanol. So what are primary alkanol? The hydroxyl bonded carbon is being attached to only one alkyl group. So let's take a look. Hydroxyl bonded carbon, you can see. This is our hydroxyl bonded carbon. That is the carbon that is attached to the OH. You can see it. And it is being attached to only one alkyl group. That's primary alkanol. The secondary alkanol, you can see it being attached to 2 alkyl group, and you can see the tertiary alkanol being attached to 3 alkyl group. That's about the classification of alkanol. Don't forget our short trick of identifying this primary, secondary, and tertiary. This is the most important part of all this classification. It is commonly asked in almost all exams, whether you are talking about WAEC, JAMB, Post-JAMB, NECO, or any other form of exam. They usually ask about this classification, which is based on the number of alkyl groups surrounding the hydroxyl bonding carbon. And what's the trick? Once you see that your OH is on carbon number 1, once your OH is on carbon number 1, you know that it is primary, like methanol. You can like ethanol. You know, ethyl 1-ol is the same thing as ethanol. Propyl 1-ol is the same thing as propanol. Butyl 1-ol is the same thing as butanol. One, they didn't mention the number, like the position of that OH is on carbon 1. So once you see that your OH is on carbon number 1, it is primary alkanol. That's the first trick. So the second trick is that tertiary alkanol, your hydroxyl group and your alkyl group must be on the same carbon. That is, if I have something like 2-methyl propan 2-ol, you can see 2-2. 2-methyl, the alkyl is on carbon 2, propan 2-ol, the OH is on carbon 1 to carbon number 2. So you know it is tertiary. Or another example, 3-methyl pentan 3-ol. You can see your alkyl is on carbon number 3 and your hydroxyl is also on carbon number 3. So that's tertiary. You don't need to even waste your time at all. Another typical example is what? 2-methyl butan 2-ol. You can see 2-methyl butan 2-ol. Both the alkyl and what? Hydroxyl group are on the same carbon. That's also tertiary. So once they are not primary and they are not tertiary, what's your answer? Secondary alkanol. Secondary alkanol. Thank you very much, everyone. I post some questions on my comment section. Kindly try as much as possible to comment your answer. Thank you very much. Good day.